Welcome back to geometry. We are at section 4.2-3, triangle congruence by side, 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 angle, and angle, angle, side. I'm going to start off with a new term called an included angle. And that's going to be an angle between two sides. So when I look at this shape and I start with angle A, so let's go get this down in writing. How come that's not writing? I can say that angle A is the included angle, and so the word included means between. So angle A is between segment BA and between segment CA. And I can say that angle B is the included angle, or is in between segment AB and segment BC. And then our last angle, angle C, would be an included angle, and so for sides or segments AC and BC. We also would have what's called an included side. So on the included side, it's going to be the side between two consecutive angles. So let's start with segment AB. And segment AB, or side AB, is the included side for angle A and angle B. And segment AC is the included side for angle A and angle C. And segment BC is the included side for angle B and angle C. Alright, before we move on, I want to review a little bit more. So let's do this. Let's draw two equilateral triangles. Let's get this drawn right. Alright, so here all these sides are the same. Alright, and then we're going to draw this equilateral triangle as well. And you're going to be told that all of these sides are the same length as all of these sides on the left. So, these two shapes have the same size. Now, yesterday in class, we learned that in order for two shapes to each be congruent, you need you need three sides and three angles to all be each congruent. And if that happens, then these two triangles are congruent. Okay, well, looking at this, are these two triangles the same? Are they each congruent? Well, we know that all three sides are because they are marked. What about their angles? Are their angles also going to be the same? Well, the answer to that is yes, because in an equilateral triangle, all angles are going to be 60 degrees. So all these angles are 60 degrees, 60 degrees, 60, 60, 60, and 60. Therefore, we know that these two shapes are congruent because all sides and all angles are each congruent. Alright, now what if we switched it up? Alright, now before we switch it up, looking at what we have here, do you see how we have side, 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 and side, side, side? There's a rule that we'll learn on our next page that says when you have three sides that are all the same, you can then say that the shapes are congruent, and that's known as side, side, side. We also have, let's circle this. There's side, side, side. We also have what's called side, angle, side, and angle A has to be an included angle. And then we also have what's called angle, side, angle, where the side is going to be an included side. So that's why it's important that we understand the terms included angle and included side, because we use them in these new rules that we have. Alright, and then let's get back to this simple problem. So let's draw two equiangular triangles, and all these angles are the same, so 60, 60, and 60. And I'll draw a second equiangular triangle, and 60, 60, and 60. And let's make this a little bit bigger. Alright, there we go. So looking at this problem, I'm going to ask again, are these two triangles each congruent? Well, over here, they ended up being yes, because all three sides and all three angles are each congruent. In this problem, what do we know? Well, we know that all three angles are congruent. So we are shown that. It's given to us. But do we know that the three sides are congruent? We do not know that. We are not told that these sides are the same. Just because these angles are the same does not mean their sides will be the same. So in a sense, this is kind of a trick question, because we can't assume anything. To see it better, let's say we had this 60, 60, 60, and then let's draw this 60, 60, 60. Now hopefully you can see that these two shapes are clearly not congruent. Even though they have three angles that are congruent, they do not have three sides. The three sides aren't congruent. Therefore, these two shapes aren't congruent. And this brings us to a point, because here we have angle, angle, angle. So angle, angle, angle will not work. This is not a rule that will work in geometry to prove that triangles are congruent. The only ones that work so far that we will learn is side, side, side works, side, angle, side, angle, and angle, angle, side, which we'll learn on the following page. Alright, we're back. First term we have is called our side, side, side. And note up on top that this is a postulate. Remember that in geometry, this is an accepted fact. Okay, meaning we won't or we can't prove it. Okay, so remember that in theorems, with theorems, we always have to prove that a theorem works, or we will prove that theorems work. On our term that's called postulate, it's just an accepted fact. We don't have to prove it. It's just what's so, right? I mean, it's just what is, it's just a fact, okay? So we're not going to prove why these work. On side, 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 it's easy to see why side, side, side works. You know, if we think about if all three sides are each congruent, that means that their angles would also each be congruent. So this one's easy to see. The other ones aren't so easy to see as side, side, side. Now, we should always mark this. So we would need to be shown that side AB is congruent equal to BE. BC is congruent equal to EF. And AC is congruent and equal to DF. And so triangle ABC is congruent equal to triangle DEF by side, 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 and say SSS. Alright, next rule is going to be side, angle, side. So let's get this down. Side, angle, side. Okay, and we would need to be shown this. So we need to be shown that AB is congruent equal to DE, angle A is congruent equal to angle D, and AC is congruent equal to DF. And if we were shown that, then we can say that these two triangles are each congruent by side, angle, side. So what's interesting to note, again, is that yesterday we had to prove all three sides and all three angles were each congruent. And if we could do that, then we could say that the two triangles are each congruent. Well, what's nice about this is these are now shortcuts. We don't have to prove all three sides and all three angles are each going to do the same. We just have to prove side, angle, side, and by this rule, we can then say that these two triangles are each congruent. And so in a sense, it's a shortcut for us. It's nice that we don't have to prove all these angles and all of the sides. We can just stop right here and say, okay, we have enough information given to say that these two triangles are each congruent. Alright, sometimes it helps to draw or redraw certain triangles, meaning, let's highlight this triangle. You have one triangle on the left, and you have this triangle on the right. And so I think it's helpful sometimes to separate these triangles, because we are trying to prove that these two triangles are each congruent, okay? And we're being asked specifically by side, angle, side. So again, we don't need to prove all angles and all sides are the same, we're just being asked SAS. So let's redraw this triangle in pink. And we have to be careful about which angles we label. So it looks like A would clearly go on top. There's angle A. Looks like C would go on the left. Looks like D would go on the right. I'm going to do the same thing for the triangle in blue. And I'll try and draw this the same side. That's not bad. Alright, and it looks like angle D goes on top. It looks like angle D for the blue triangle actually goes on the left, and angle C goes on the right. Now that's important, because if you would have flip-flopped D and C here, the whole problem is going to be wrong. Okay, so it's important to see that when you separate these shapes, this is what they actually are. These angles, so here we have, angle A and angle B, which that checks out. We have angle D and angle C, and here's angle, here we go, so here's angle D and here's angle C. That checks out, and then angle C and angle D, which is what we have here and here. Alright, next we want to mark these up just the way they appear. So we have AD, we'll put a single mark at AD and BC. And we have angle ADC, which would be this angle here, and angle BCD, which would be this angle here. So this is furthermore proof that what we have drawn is now correct. So they're asking us, what else do we need? What other information do we need to prove that these two triangles are each congruent by side, angle, side? Well, here we have a side, an angle, a side, and an angle. If we were told that CD was congruent equal to DC, if we were told that, let's put 2 marks, then we can say that these triangles are each congruent by side, angle, side. We're going to do the same thing on the right. So here's this triangle on the left. We have this triangle on the right. And this time I won't separate them because it's good to know how to do them each way. So we'll just go ahead and keep these triangles where they're at. Let's mark what's given. We have RG and RH, so let's put a single mark. We're being told that they want us to prove this by side, side, side. And what other information do we need? So at first it looks like we need a lot, but we only need one side, because hopefully you can tell that this segment, or this side, is shared by both triangles. And since it's shared by both triangles, put 2 marks here, because it's going to be, this segment is congruent to itself. So we don't need this, but what I can say in a proof is that RS is equal to RS. That would be our statement, and the reason would be because of the reflexive property. So we use this a lot when we do proofs with triangles, because there's always usually a side or an angle that's shared. So we can say that this side is shared by the reflexive property. So the other piece that we would need to be shown is that if we knew, or if we were told that GS is equal to HS, so that's what we need to be shown. GS is equal to HS. If we were shown that, then we could use side, side, side to say that these two triangles are each congruent. Alright, next one we have is called angle, side, angle. So let's get that written down. We have angle, side, angle. And alright, let's make our markings. We have an angle. And note here that this side, this has to be an included side. It has to be between 2 angles. So let's mark angle C and angle F. And if I mark these 2 angles, then the side that we would need would be AC and DF. So when you have 2 triangles that are marked like this, you can say these 2 triangles are each congruent. Triangle ABC is equal to triangle DEF by angle, side, angle. And so again, these are because I don't have to prove all sides and all angles are each congruent. Once I prove angle, side, angle, these two shapes are each congruent. Alright, next we have angle, angle, side. So we have an angle A and an angle D. Now, I'm going to put a star or a little hash mark by this one. This is the most challenging one to see. It's the one that we'll usually miss on a quiz or a test. So review this one because it is somewhat challenging to see. What makes it confusing is that it's not an included side. The side will be outside of your two angles. So let's go back to the same problem we had here. We had angle A and B, angle C and F. Let's do the same marking to it. Alright, this time the side can't be included. So you can either mark A, B, and D, E, or B, C, and E, F. It's your choice, either one works. So let's put a single mark here and here. So if you were shown these two shapes, you have enough information to say that these two shapes are each congruent. And why is that? Well, that's by angle, angle, side. Alright, next, which two triangles are congruent by the angle, side, angle postulate? Well, here we have angle, side, angle, and angle, side, angle. This is just side angle. This is nothing. So let's start it off with triangle, let's start off with triangle cat. What's important is we have to now say that triangle cat is congruent to triangle dog. But if you say that cat is going to be equal and congruent to dog, you're going to miss it because it's not dog. I mean, it's this same triangle, but angle C is the same as angle G. You have one mark and one mark, so there's your G. A has 2 marks. D has 2 marks, so you have to go GD and then T and O. And so that's how we would say that these two triangles are each congruent. Triangle cat is congruent to triangle GDO. There we go. Cat is congruent equal to triangle GDO by angle, side, angle. And the side is included. There's an angle, side, angle. Alright, for problem 4, which two triangles are congruent by angle, angle, side? None. None of these are displaying angle, angle, side. This is just angle, side. This is angle, side, angle. So none. Alright, are the triangles congruent? You need to, you need 3 parts. You want to mark the given, mark the congruent angles, and mark the congruent side. Now this is great practice for proof, so let's do a 2-column proof for all of these problems. It's not going to be fun, but it's great practice. So the challenge here is going to be to fit all this in, but we can do it. So statement 1, we always want to start with what's given. We have UX is congruent equal to WX, and that's going to be given. Also G. And that's what this mark here and this mark here. Let's call this angle 1 and angle 2. Angle 1 is congruent equal to angle 2, and that's because all right angles are congruent. And then statement 3, we have to think outside the box, and we have a side and an angle. We don't have anything else. Now, we're being asked to determine if these triangles are each congruent. I would understand if you thought the answer is not enough information. I mean, clearly, we only have one side and one angle. We don't have enough information, but we do. We're back to reflective property. This side is shared by both triangles. We'll put 2 marks here. And now what's shown is side, angle, side. So for statement 3, we want to say that this segment, which I can't read it, there we go. We're going to say that dx is congruent equal to dx. And why is that? That's because of the reflective property. That was statement 3. And then statement 4, we have to say that these two triangles are now each congruent. So let's go u dx. And if I went u dx, I would have to call this triangle w dx. So these two triangles are each congruent. why is that? The reason would be side angle side. Next triangle. We're going to prove, hopefully, that these two triangles are the same. Let's set up our two-column proof. So we can squeeze this in. Statement reason. And we want to always start with what's given to us, what's shown. We see AP and BP, so let's get that down. AP is congruent equal to BP. That's going to be given. And what else are we shown? We're shown that angle A is congruent equal to angle B, and that's also G for it. It's given. Alright, so again, we're being asked, do we have enough information to prove that these two triangles are the same? So we have this triangle on the left and then this triangle on the right. Are these two triangles each congruent? We have an angle, a side, and a side. So you might think again there's not enough information. However, there is, because remember that vertical angles are always going to be equal. They're always congruent. So we're going to say, alright, we can't say that angle P is going to be equal to angle P. There's two angle P's. Okay, we only had one angle A and one angle B, but for P we have two of them. So let's use our shortcut. We'll say angle 1 and angle 2. And I'm going to say that angle 1 is congruent equal to angle 2, and that's because vertical angles are always congruent. Alright, and then my last statement is going to say that these two triangles are each congruent. So triangle, let's go ATS, is congruent equal to triangle BPY. And why is that? Well, that's going to be angle side angle. So the reason is going to be angle ASA, angle side angle. Alright, next proof. Let's do our two columns. And actually for these two shapes, we don't have to do a proof, and here's why. I can look at what's given. Now, note that these two triangles aren't shared. So it takes vertical angles out, it takes reflexive out. We don't share anything here. So we just have to go off of what's marked and what's given. We have a side, and an angle. And we have a side, and an angle. Now the angle is not included. So we can't use SAS, that won't work. And it's not like we can use side, that won't work because we only have two sides. We can't use angle, side, angle, we only have one angle. So that won't work. And we can't use angle, side, again we only have one angle. So none of these will work. And so we would say not enough information. We're not sure, not enough info. One more thing to note is that this is actually known as side, angle, and I won't write it the reverse way because you can tell that it would spell a bad word. But good thing in geometry, this will not work. We can't use it. So when we see it, we can laugh to ourselves, but we know that we can't use side, angle to prove the two triangles are each congruent. Alright, our last shape is going to be the most challenging one to see. So again, here we'll use this statement reason for this triangle here that we have. So we have the one triangle on the left, we have the other triangle on the right. We have these two sides are each congruent, so let's start off with what's congruent. DE is congruent equal to, and if I go to DE, I would have to go HG. That's going to be given. Alright, next we have vertical angles here. So let's put an angle mark and an angle mark. Let's call this, here we go, angle 1 and angle 2. So let's say that angle 1 is going to equal to angle 2, and that's because vertical angles are always congruent. So I have angle side and angle side, but note we have these arrows. These arrows are a huge clue. Okay, and when we have these arrows like that, it's probably in our best interest to extend out this line, extend out this line, extend out this line, and then extend out our stick out better. So here we have two parallel lines that are cut by a transversal. And when that happens, we know that alternate interior angles are going to be each congruent. So I could put 2 marks and 2 marks here. I could also put 3 marks here and 3 marks here. These are alternate interior angles. So for statement 3, let's say this is angle 3, and let's say this is angle 4. And again, this is hard to fit everything in, so I know this is challenging to see, but angle 3 is congruent equal to angle 4. And why is that? Well, that's because alternate interior angles are congruent. Okay, so that was reason 3. Alternate interior angles are always congruent. And therefore, we have angle, angle side, and angle, angle side. So I can say that these two triangles are congruent. Let's go triangle depth. Is congruent equal, and if I go depth, I went 2 to 3 to 1. So 2 to 3 to 1, that would be triangle GHF. These two triangles are each congruent. Alright, last two proofs. Let's go ahead and mark what's given. You have WX is congruent equal to YZ. We have XY is congruent equal to ZW. So again, we want to circle everything that's given that goes into the first statement box, and that's given to us. And then remember that whatever we're trying to prove is going to go into the last statement column, so that's what we're trying to prove. And so up here in our notes it says have a plan. So before we solve this, we just kind of want to look at the shape, look at the problem, and look at what's being asked to do. So they want us to prove that these two triangles are each congruent. From the outside, it looks like these two triangles are congruent. Here's one triangle, and then here's the other triangle in green. So it does appear that these two triangles are each congruent, but remember we need proof in geometry. So we have side, side, and side, side. Hopefully you can see that this segment, or this side, is being shared by both triangles. And if it's being shared by both triangles, it's going to be equal to itself. So that's where reflexive property comes into play. We can say that WY is congruent equal to WY. Therefore, we now can say that these two triangles are each congruent. Why are these two triangles each congruent? Side, side, side. Next proof is more challenging. Again, let's mark what's given. We have WX and YZ. We're told that these two lines are also parallel. Okay, so again, we circle all of this. It's going to go into this first box. It's given. Lastly, we're going to circle all of this. It's going to go down to the last box in the fourth. And so whenever we have lines, first. Do you see how this line, or this side is shared by both triangles? So do you see that by now? So we're going to put 2 marks here. So we're going to say that WY is congruent equal to WY. Alright, next, let's extend this out. The reason why I'm doing that is I was told that these lines are parallel. Whenever that happens, it's usually going to set up alternate interior angles, and so it helps us to extend out the 2 lines that are parallel and then extend out our transversal. So we're back to unit 2, which is what we did last unit. We have 2 lines that are parallel cut by a transversal. And so when that happens, hopefully you can tell that, let's change my color, hopefully this will stand out better. These are alternate interior angles, these 2 angles here and here. And these 2 angles are also alternate interior angles. And that's hard to see, but it is true. These are alternate interior angles. So they're asking for angle XWY. So that would be this first angle here with 1 mark. So let's call this angle 1. And then angle ZYX would be this angle here, angle 2. So in a sense, they're saying that angle 1 is congruent equal to angle 2. And this is true because alternate interior angles are congruent when 2 lines are cut by angle and a side. We have a side, an angle, and a side. We also have an angle, and a side. So we have two ways that we can prove this. We can say that these two triangles are the same by side, angle, side. Okay, or we could also use angle, angle, side, because we've shown that these triangles are the same. Now, if we did use this reasoning, we would have to make one more statement called 3b, and let's call this angle 3 and angle 4. We would need to first say that angle 3 is completely equal to angle 4, and that would be, reason 3b would be alternate interior angles. And then now that we've listed that, then we can jump to our conclusion that triangle WXY is true and equal to triangle YZW. Okay, and that would be by angle, angle, side. But that's a little more work, so I probably just would have stuck with side, angle, side. Alright, the graphing, we definitely need practice on graphing. Go ahead and hit the pause button. You can try it first and then check the answers with mine. So across the y-axis at -4, slope is positive, and go to the right, right 2 and 3. If you don't know how to graph using point slope, solve for y, that becomes -4x plus 4, y equals -4x plus 2. And then 3x is equal to 12, x equals 4, -3. And then y is equal to 3, and when crosses the y-axis. On this graph, I just said 3x is equal to 12, which means the x-intercept is going to be 4. And then -4y equals 12, which means the y-intercept is going to be -3. And then I do my graph. Thanks for joining us. See you next time.